Hi everyone, my name is Brandon Laguerre and this is the final presentation for Group D. Our project is the Distributed Sound Event Location System, also known as DIESEL. On the hardware team, we have myself and Chris Santana, and on the software team, we have Mark Judy and Drew King. For both humans and animals alike, the sounds we hear play a major part in allowing us to communicate and quickly make observations about the world around us. However, we're not always here to hear these sounds, so the main goal of this project was to use technology to convert the surrounding sounds into more useful information. This information can be used for many things, such as increasing safety and security, research, conservation of animals, or general hobby activities. We wanted to achieve this using a few major steps. First, a sound event will occur that will trigger a network of audio sensors. The GPS and sound data from the sound event will then be sent to the sensor server to determine the location of the sound and store the audio information. Then, the sound will be classified and sent to the web server, which will display the ID and location of the sound to the user.
The design philosophy for our user interface was to create something that was informative and easy to use. There are two main sections built out of Angular. Behind the scenes are Node.js with Express for the web server and MongoDB for the database. On the left-hand side shows the user each classification event occurring with our system along with the data collected. On the right, the user is displayed the single-tone multilateration events. They can view the data numerically as well as add markers to the map for a visual and remove them from the map when needed. To keep all the information up to date, the user interface is updated every 30 seconds. The four sensors are put in a rectangular pattern. A signal is then sent out, and with the use of multilateration, the location of the signal is found.
The system works through multilateration, which is the same technique used by GPS. Each sensor records the time of arrival of a sound. Sounds further away take longer to arrive because of the propagation speed, right? The speed of sound. But we don't know the time of transmission of the sound. We only know the relative difference between the first sensor to hear it and the rest of the sensors. 3+ sensors are needed for 2D location, because if you had only 2 sensors, then it could be on one of 2 sides. 3 constrains that to a specific location. However, ambiguous results are given if the origin is outside of the area encompassed by the sensors, because we only know the relative time of arrival at each location.
When everyone was not able to work in person, our team was able to collaborate by using Discord. Discord allows multiple people to talk over voice and text. With Discord, we were able to keep each other updated on our progress and share pictures and videos. During planning, a difficulty our team faced was that we had conflicting schedules. We were able to overcome this by scheduling days in advance for us to collaborate. We also used Trello to outline what everyone was working on. What motivated us to stay focused was our desire to graduate. We each knew that each other's grade depended on the work that we did. We used this to our advantage by working as hard as we could to produce a project that we could all be proud of. The biggest lessons we learned throughout the project was how to design and create a PCB. We learned how to design a PCB in Eagle and how to send those designs to a PCB manufacturing company. We then learned how to solder surface mount components using a hot air rework station.